Okay, let me tell you about rational exponents. What does that mean, rational? Rational means fractional. So I'm talking about fractional exponents. Okay, so for instance, rewrite. Rewrite the expression, let me say 625 over 28,561 to the 1/4 power. Okay, when I say rewrite, I mean rewrite it with a radical. Okay, so this is actually the same thing as I've got what looks like a square root symbol here. But it's actually not square root, it's fourth root. This denominator tells me that the index is going to be 4. You can actually split this up into the fourth root of the numerator over the fourth root of the denominator. So fourth root of 625. Okay, so get a calculator for that. The denominator, fourth root of 28,561. Okay, got a calculator? Consult your owner's manual with regards to calculating fourth roots. So the numerator, my friends, is 5, and the denominator is 13. So that's the answer that he wants. Okay, how does that look to you? What? Okay, now consider this. For instance, let's just say I've got 16 to the 3/4 power. Okay, well, the numerator is actually going to become the exponent on the 16. So I've got 16 under the vinculum. This horizontal line is called the vinculum. That'll be raised to the 3rd power. The numerator tells me that. The index is 4. The denominator tells me that. So use a calculator and figure what 16 cubed is. So 16 cubed, what is that, 4,096? So now what is the fourth root of 4,096? That'd be 8. So the answer he's looking for, 8. Got that? Okay, now consider this. For instance, let's say I've got 243 raised to the power of negative 4/5. What does that mean to have a negative exponent? I can make the exponent positive if I move it into the denominator. So this is the same thing as 1 over 243 to the positive 4/5 power. I can make that exponent, make it go from negative to positive by sticking it in the denominator. Okay, now tell me, 243 to the 4/5 power. I propose writing that as, okay, so what's the exponent on 243 going to be? What? It'll be 4, won't it be? And then the index is 5. See, numerator becomes exponent, denominator becomes index. Okay, so go ahead and calculate this. You'll find, my friends, that this is 1 over 81. How does that look? Got that? Okay, now consider this. Let's say I've got negative 3 to the 3/4 power. How do I deal with that? Okay, well, I'll have here negative 3. Numerator becomes exponent. Denominator becomes index. How's that? Okay, so simplify under the vinculum first. So the negative 3 cubed part, isn't that negative 27? Okay, now what's the problem with this? I'm actually taking the fourth root of a negative number. That's not real. You'd wind up with an imaginary here, which is a bit beyond the scope of this course. But that would be a non-real solution. Well, let's do some variables. So consider this. Suppose I want to rewrite 196 x to the 18th power to the 1/2 power. So now I'm throwing in some variables. 1/2 power, that means square root. So this is actually the same thing as the square root of 196 times x to the 18th power. How was that? Now you can split this up into 2 separate square roots. The square root of 196 and the square root of x to the 18th. Use your calculator to find the square root of 196, or maybe you know it by inspection. That's 14, isn't it? Now the x to the 18th, I can write that as x to the 18th. The square root part, that becomes exponent 1/2, doesn't it? Okay, so the 14 is just 14. Now what about x to the 18th to the 1/2? What can I do about that? Remember rules of exponents? When you raise a power to a power, you multiply the exponents. So when I multiply 18 by 1/2, I get 9er, don't I? I get 9, or 9er as I like to say. Okay, so the answer he's looking for, 14 to the 9th power, I mean 14x to the 9th power, pardon me. Let me fix that. Okay, let me try this again. So 14x to the 9th power, it's a good thing I caught that. Okay, now it's correct. Let me move the pencil. Okay, so 14x to the 9th. 14 is 14. X to the 18th to the 1/2, that's x to the 9th, isn't it? Okay, how about this? Consider 2 over x to the negative 4/5 power. Now, usually books will give you the directions as rewrite with a positive exponent. Generally, we like to use positive exponents. So if the exponent is negative, and the expression is already in the denominator, if I move it into the numerator, the expression, the exponent becomes positive. So you notice that the exponent is negative 4/5 when it's in the denominator. When I move it into the numerator, it becomes positive 4/5. The 2 is just a 2, you see that? You see what I did here? So that's the answer he's looking for this one. Okay, so with this one, once again, I want to write this with positive exponents, x to the negative 2/5 times x to the 1/4. Rewrite that with a positive exponent. Okay, well, when I'm multiplying powers with the same base, I add the exponents, don't I? So the exponent will be negative 2/5 plus 1/4, you hear? Okay, can you add negative 2/5 and 1/4? Okay, so this will be x raised to the power of, what's the common denominator, 20? So 8/20th plus 5/20th. Got that? So this will be x raised to the power of negative 3/20th, won't it be? Negative 3/20th? Okay, so I've got here negative 3 over 20. Is that correct? How does that look? Okay, writing it with a positive exponent, it'll be 1 over x to the positive 3/20th. Okay, you satisfied with that? How does that look? Okay, now let me show you something. Consider this. Simplify 16y to the 4th power to the 3/2 power. Okay, well, that exponent, I can apply that to the 16 like so, and I can apply it to the y to the 4th like so. You see what I did here? What? Okay, so let me try that again. I take the 3/2 and I apply it to the 16. That's what you see here. And then what did I do? So switching to green here. I take the 3/2 and apply it to the y to the 4th. That's what you've got here. Okay, how does that look? You satisfied with that? Okay, what is 16 to the 3/2 power? If you got a calculator, try taking 16 and raising it to the 1.5 power, because 3/2 is the same thing as 1.5. Now for the y, multiply 4 by 3/2. Okay, so here you'll have 4 times 3/2. Okay, so did you figure out what 16 to the 1.5 power is? I did. That's 64, and then y raised to the power of, what's 4 times 3/2? What is that, 6? So 64y to the 6th. 64y to the 6th, you satisfied with that? Okay, how about this? X to the 2/3 times x to the 5/9 over negative x to the 5/6. Okay, first of all, I'm going to move that negative out front. Okay, I'll have x to the 2/3, x to the 5/9. Those are in the numerator and will remain so. You see that x to the 5/6 in the denominator? You can move it into the numerator by making the exponent negative. So that x to the 5/6 that's in the denominator, if you move that into the numerator, the exponent becomes negative. You see that? Okay, so what I'll have here is negative x. I've got 3 exponents here. I get to add them. So 2/3 plus 5/9 plus negative 5/6. How does that look? You see how I'm adding those exponents? Okay, so the negative is still there. Don't forget about that. That'll be negative x to the 7/18 power. Okay, so that's the answer he wants. Negative x to the 7/18 power.